How's it going, everyone? Meulier again. Now, today we're gonna finally focus is on this particular course because over the couple weeks, specifically over the past almost 2 months, I dedicate time to actually learn and understand deeply what is React of that. So specifically from their docs, right? This learn model as a way to understand and be able to describe is that all of these different aspects of React, and luckily for me and for us, we actually get this uh, learn section where we go over all of this as a way to create now this storytelling, which as human we make sense the world through stories. So by looking at describing the UI and adding interactivity and then managing states and then ultimately escape the hatches, okay, uh, we are now going to see what is this course about, or what is the skills and techniques that we're going to absorb, we're going to apply when we are writing is React components. And if you want to do that in the most performant way, what are those techniques? So, so far we look that because in the React application we know how to do that, and that is um, usually is understand what is performance, okay, and performance at the end of the day is in the context of React is not doing stuff is way much faster than doing it, and there's some corollaries to that, such as doing things later is much faster than doing it right now. So the whole point of this is to develop this notion, not only that you can apply to your life, but also in the React context. And what is the value proposition of this course as a way to, once you understand what React does, then you want to identify what are the common performance issues that you can encounter, and then you develop now a tool set that allows you to identify each one of them, and then apply the best practice to solve them. And that's pretty much what this all about. So today's video is going about is looking at the React rendering and reducing rendering, but specifically this one from that particular course, and how now we look at how to understand is, so what is React behind the scenes, the React DevTools, as well as the profilers, and how now Steve actually mentioned that uh, as a way to now understand is the intrinsic part of React, which is something that I'm quite familiar with. So we got the pre-render period, what states are, and how reactive rendering works. All of this has been done. And how now it describes is the different phase that can happen. But instead of actually going with this, okay, which is pretty much what, based on his experience, he mentioned, right? This is React rendering cycle. The render phase, the commit phase, and the cleanup. Uh, that's right. I will say the trigger, render, commit, and cleanup phase if you're having is effects, okay? And how it is important to actually think of them as different. This is when you're mounting. This is your updating. Use stay, use reduce, or use callback. And the commit phase is when you update the DOM plus the ref. After the commit phase, when the use effects and the use layout is run, and then now they run in the cleanup function. And what is now this fiber, which is, or at least is the fiber like this. Where now fibers, there you go. We're now Fiber. You can read all of this about in the famous engineering problems. We rewrote React. Fiber is responsible for most of the new features in React 16, like error boundary and fragment. Over the few over the next few releases, we can expect new more features as we begin to unlock the full potential of React. Perhaps the most exciting area we're working on is async rendering, and now we know what is that. A strategy for cooperatively scheduling rendering work by periodically geo execution to the browser. Perhaps the using is now generator from that. Even though in the name they tell you do this. The upshot is that with async rendering, apps are more responsive because React avoids block the main thread. And now that's when they develop this concurrent rendering or rendering prioritization. Uh, but again, Fiber, let me see if they describe this. Uh, but React Fiber, you take a look at this. React Fiber is now the reconciliation engine. There you got it. This is the reconciliation engine. And you may wonder where did I get that? I get the done with the elements and that kind of things. So what is React Fiber? It's the new reconciliation engine in React 16. It is the main goal to enable incremental rendering of the virtual DOM. So as you can see, this React Fiber is the reconciliation engine. And that is the part where now, as the rendering happens, caused by the state updates, React will recreate the VDOM, this ideal representation of the UI, keep in memory and sync with the real DOM. So this piece of code, this particular process here, is something that will unlock all of these particular features that we are now capable of, such as concurrent rendering or rendering prioritization and that kind of thing. So far so good. Okay, because the idea of today's video, even though they mentioned fibers and keys, React tries really hard to keep track all of the components instance. A fiber is a fancy word for a very cool data structure that React used to keep track the components instance. And when adding, removing, or changing the order of the collection, having unique keys allow React to keep track all of which is ideally what you want. And the another thing that you have is automatic batching or the updater function. If you trigger multiple state changes in a single pass, React will batch them before dragging through the whole process. And this is our reflections. It's like keep the state update logic maintainable. We know how to do that. Preserving the state and reset state. But yeah, today's video is all about is now the React rendering cycles, React fibers and rendering, and find a performance issue here as it is. And what is the tool? What is the tools or the series of steps we need to go as a way to now identify any performance issue? So you looked at the React live site is using the production flag. If it is, then you move to the render tree, the way this component is architecture, the relationship, as well as it is a state. You start from then, you identify if you have any performance issues. Remember, any rendering, block rendering, or you are re-rendering anything that is, or you are re-rendering things that you don't need. the strict mode actually help you to do this? Uh, then, if it's not, then you take a look now at what is your catching mechanism. So, for example, in your React component, it's like, hey, are you using is perhaps use Mimo or use callback to reduce rendering, right? And how you can use that using the reducer, and also um, using the context API as well to reduce the rendering. And when it comes now to use this, for example, uh, when this component is loaded, you can use this suspense as a way to determine that. And also, last but not least, if you're in a real pickle, well, you are going is to use now is transition or use defer values for that. But let's take a look at this. Take a look. Right now, you're not gonna see what I'm going to do. In fact, it's because I don't want to receive any flag. Not at all. I already received a flag from frontend master. Uh, and yeah, that's right. It's like no thanks. No thanks.
So now, let's talk about how does React do what it does.
So we were talking about is the React rendering cycles. Okay. Let me see what is your description.
Right, because it's really hard to like triage and think about what could be the cause of the issue. If you're like something virtual DOM, life is good, right? And so let's talk about like how when something changes, what exactly goes on under the hood. So React's rendering cycle has effectively 3 phases, and I think we mostly know about them, right? And so we have the render phase, and this, I think that the whole like, it's not necessarily true. It's like there is a virtual DOM, and like that was definitely true in 2013. It is increasingly less true at this point. But the process still, and we'll see this in another slide to see actually how it plays out, which is the rendering phase. Like, I think that the whole like, it's not necessarily true. It's like there is a virtual DOM, and like that was definitely true in 2013. It is increasingly less true at this point. But the process still, and we'll see this in another slide to see actually how it plays out, which is the rendering phase. Like our components at the end of the day are a bunch of functions or possibly JavaScript classes. And so when something changes, because like once we render the page, if the user never clicks on a single thing ever, you don't have performance issues. It's only they took some kind of action, or like you had like you're polling for the API every 30 seconds. Like something has to happen to trigger a re-render. Like React does not choose to re-render on its own. Something occurred, either through your code or most likely because the user did a thing, right? They tend to do that on applications, right? And if they never do a thing ever, I wonder why this is a React app and not either A, a server-side rendered app, or B, just an HTML.
Exactly.
Those are super performant, right? You want to solve your React performance problems, that's the way to do it right there. So when something changes, we go through the render phase.
Exactly.
Right? They tend to do that on applications, right? And if they never
if they never ever do anything like that, it's like I wonder why you actually are writing your React application
ever,
because you
I
can
wonder
actually
why
write
this is a React app and not either a server-side rendered app or B, just an
app or just an HTML page.
Those are super performant, right? You want to solve your React performance problems, that's the way to do it right there. So when something changes, we go through the render phase, which is it calls it invokes all the classes, it calls all the functions, it looks at the output, and goes, what's different from last time, right? And gathers up all of those things. And then with the array of things, array is probably an overloaded word, with the list of things that have changed since the last time it rendered, it goes and figures out what the most heuristic set of changes, most performance set of changes to the DOM are to make, and it makes those, right? Like it is one of those things where, yes, if you were going to sit there and handcraft every change on the page, you could probably beat React. But as a general heuristic, it has a set of rules that it applies on what the right thing is to do most of the time, and it works. And that's when it enters the commit phase. It takes this list of changes it needs to make to the DOM, and it does them. It updates the DOM, right? And if you ever,
that's what the commit change said.
Takes this list of changes it needs.
Exactly. That's what the commit said. You don't know if that actually working is with Rhythm or if it's something list from React 16. Yes, but in React 18 does not. Do I need to look at the code to actually see if that actually working as expected or see that is true?
Now let's talk about how.
Because at this point, what is doing React behind the scenes, or at least in this, is to now, of course, they're not going to reveal that. Or, I mean, they did, but because this is open source, it's like, React, installation is React, React VDOM. Again, this is from the old docs. Copyright 2024. So what is React Fiber? Okay, so when you take a look now at this, React Fiber is an ongoing implementation of the React Chords algorithm. Uh-huh. So they're actually changing that algorithm. So you are not sure that actually is using the video behind the scenes, because even though that this docs is quite old, so React Fiber is an ongoing implementation of the React core algorithm. So they perhaps they're using it as a VDOM. Who knows? At this point, you need to actually take a look behind the scenes. It's the culmination of over 2 years of research by the React team. 2 years. The goal of React Fiber is to increase its suitability for areas like animation. Oh, okay. And they tell you here the goal of React Fiber, which is this reimplementation of the React core algorithm. Remember that after all, React just wants to allow you to describe its UI state and keep track all of this. So because of that, the goal of React Fiber, this list, the goal of to keep track all of this state updated, uh, is to increase its suitability for areas like animation, layout, and gestures. Very specific. That again, this is for Facebook problem to solve. This is to solve Facebook problems. Animations, layout, and gestures, so you can see where the thing is heading at, is going. Its headline feature is incremental rendering, the ability to split rendering work into chunks and spread it over multiple frames. In the context of this, it's like, hey, okay, I'm going to now have the ability to split rendering work. Hey, I want you to know rendering is this, whether it's an animation, layout, and gestures, and I want you to do that over multiple frames. Other key features include the ability to pause, abort, and reuse work as new update comes in. The ability to assign priority to different types of updates, a new concurrent primitive. But the whole goal of this React Fiber architecture, which is a re-implementation of the React core, and this is something important to understand, especially if you're gonna work with this tool, because you know how to wield that pretty much like a mouse or a keyboard or a mobile, um, or even a lighter like this. Once you know this, it's like, all right, you know how that things work, and you can actually, even though that it is primary, or it doesn't contain, for example, this actually doesn't have any oil in there, like it's out of gas, by the way. But as you can see, that this actually now provides you is what you need, which is the spark. You see where I'm going? Is that it pretty much is this. The only reason, or the only different thing, is that because this is quite abstract, it is less tangible. So things can happen quickly, and because you don't have that sensation, that feeling is like, can give you the false sense that it's not happening. That's why when you read this kind of thing, it's important to think about that using a particular real life sample as a way to now, from that abstractions, get something that you can work with, an idea, an example that you can work on that. So React Fiber, according to their docs, updated 8 years ago. Holy moly! It's an effort. It's an ongoing so the React Fiber is an ongoing implementation of the React course algorithm. So initially start with a VDOM, okay, as a way to how they can sync, how you can represent is the ideal UI and keep it sync and keep it in memory and sync with the real DOM. This reconciliation process, but as the time goes, I don't know. They mentioned that they in 2016 they went through uh, re-implementation of the React course algorithm. So it means that perhaps now they're not using React DOM any longer. Okay. Uh, and in fact, they're using some sort of way, some sort of data structure in algorithms where now they are focused in these particular areas in animations, layout, and gestures. And that makes a ton of sense to know where this S, where the French toast these things is moving out. Okay, it is headlines, feature is incremental rendering. The ability to split the rendering work into chunks. It is headline feature is the incremental rendering, which is the ability to split rendering work into chunks and spread those chunks to the animation or to the frame over multiple frames. But this is the end goal or right now of React Fiber architecture. Pretty much like fibers, pretty much like muscle fibers. Okay, we just take a look at the muscle fibers, which is something beautiful, by the way. You know, no, this is also very very beautiful. How you understand this body, bro? This is a very very interesting thing. The skeletal, the because this is something called the skeletal muscle, and the skeletal muscle is quite fucked up because it is now bones and tissues, muscle that is joined together. And that's quite interesting. Right? Muscle type or fibers. Converted parallel from like the biceps. Circular. What? We got a circular? What the hell? We got a circular muscle type? Bimpennate. Like in, okay. Unipinnate. Okay, no, circular. What is circular? Ah, in our mouth. Okay. That makes a lot. Okay. Interesting. Interesting. That is a muscle. All right. Okay. And the multipennant deltoid muscle. Deltoid. That's quite interesting. So the reason of looking at this is because pretty much from the anatomy, okay, deltoid, it's actually something actually that I quite understand a couple of their muscle or their main muscle, quadriceps, peroneus, peroneus brevis and longus, abductor. abdominal external, rectus abdominis, pectoralis major, rotator cuff, 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 but cuff is not manguito. Ah, okay. Cuff is those cuff. Oh, handcuff. But cuff. Um, Interesting. Rotator cuff. Rotator cuff meaning the end part of a sleeve, informal handcuff. The thicker material at the end of the sleeve. Cuff, a part at the end of the trouser leg. A piece of jewelry for wearing around whistle. Exactly. It's not like they don't use that. So a cuff. A cuff in Spanish it is like wow, why bofetada? The fuck? If it is an action, if it is a verb, it's like una cadena, un arito, cuff. Exactly. Cuff. Okay. Como un aro. But this is interesting because in Spanish they call them is the mango rotadora. I don't know why in Spanish they call this manguito rotadora. Well, in any case, problema con el manguito rotador. Why the manguito rotador is the same as rotator cuff. Rotator cuff. Mm-hmm. But in any case, the whole point of this is that by connecting now is this computer science concepts here as a way to now look at all of these fibers and how you can use these specific uh, examples, like fiber, muscle fibers, okay? Where if you take a look now, the skeletal muscle here, yeah, I want to open up from Wikipedia. So if you take a look now at the muscles here, where you have now is the muscle fiber, okay? This is the muscle fibers. In each one of those fibers, you have this myofibril, which contain is this tubes. The idea of this is that with React fiber architecture, which is a reimplementation of the React core algorithm, is to aim now performance, or is to make it suitable. Is to make it suitable to work with animations, or is to increase its suitability. Exactly is to make it more suitable for animations, layout and gestures. For animations, layout and gestures, by splitting the rendering work into a small chunk or into myofibrils, okay, by splitting the rendering work into small chunk, pretty much like myofibrils, they can and spread over multiple frames, which is in spread over multiple frames, spread over multiple computation. And the whole point of looking at this is with this myofibril concept. That after all, React Fiber, which is this re-implementation of the React Core architecture, is the whole idea is to make it suitable for animations, and it's important to understand the goal. Make it suitable for animations, layout and gestures by spreading the rendering work into small uh, into small chunks of work. Okay, into small chunks of work, or into small chunks, and spread it over multiple frames. S- Split that into small chunks, pretty much like myofibrils, and spread that into multiple frames, and put and pass that multiple chunks of string, multiple of myofibril of data to the frame, which is the request animation. And again, the whole point of this is to make it more suitable for that, for animation gestures in layout. So, Fibers introduce several novel concepts that are difficult to grok solely by looking at the code. Interesting. This document began a collection of notes I took as follow along with Fiber implementation in the React project. As it grew, I realized that it may be helpful resource for others too. I'll attempt to use the plainest language possible and avoid jargon by explaining defining key terms of the architecture. I also link heavily to external resources when possible. Please note that I am not on the React team and do not speak for any authority. This is not an official document. I have asked members of the React team to review it for accuracy. Okay, this is also a work in progress, and Fiber is an ongoing project that will likely undergo significant refactor before it's completed. Okay. Oh shit. React components, elements, and instance reconciliation as well, where they say, hey, we don't find that. React basic theoretical concept and React design principles. I think the design principle is something that, well, they don't provide. Please check out the prerequisite section if you haven't already. Before we dive into the new start, let's review a few concepts. Reconciliation. Use the div one. Update. A change in the data used to render the app. Usually the result of set state eventually results in the render. Actually, re-rendering the entire app so each change only works for most triple apps. In real world, it is prohibitively costly in terms of performance. React has optimization which creates an appearance of the whole re-rendering while maintaining great performance. The bulk of these optimizations are part of the process called reconciliation, and that is an algorithm behind what is popular understood as the virtual DOM. A high-level description goes something like this. When you render a React app, a tree of nodes that describe the app is generally saved in memory. This tree has flush to rendering environment is flush. I'm not sure what flush means. Okay, it's flush. This tree is then flushed to the rendering environment. For example, in the case of a browser application, it is translated to a set of DOM operations. When the app is updated, a new tree is generated. The new tree is different with the previous tree to compute which operations are needed to update the render app. Although Fiber is a ground-up rewrite of the reconcilier, the high-level algorithm described in the React docs will be largely the same. The key points are different components types are assuming and different of a list of performing issues using keys, and keys should be stable, predictable, and unique. Reconciliation versus rendering. Scheduling. the React design principle. What is a fiber? Fiber are a much low level abstraction that application developer typically think. If you find yourself frustrated in your attempt to understand it, don't feel discouraged. Keep trying and it will eventually make sense. When you do finally get it, please suggest how to improve this section. Here we go. Okay. Is now describing is this flush output and future section. Okay. No. Okay. This is describing is this. We established that a primary goal of Fiber is to enable React to take advantage of scheduling. Specifically, we need to be able to pause work and come back it later, assign priority to different type of work, reuse previous completed work, abort work if no longer needed. The way computers typically track program execution is using the call stack. When a function is executed, a new stack frame is added to the stack. The stack frame represents the work that is performed by that function. When dealing with UIs, a problem is that if too much work is executed all at once, it can cause animations to drop frames and look choppy. The more stack frames you add to in the UI, the more it reduces the frame and looks choppy. What's more, some of that works may be unnecessary if it is superseded by a more recent update. This is where the comparison between the UI component and functions break down because components have more specific concerns than functions in general. Newer browsers and React Native implements API that help address this exact problem. But all of this is because the end goal of the Fiber is to enable the advantage of scheduling. Hey, I want you to do this task when I need it to do this. So to pause the work and come back later. Hey, let me schedule that I want to okay. And by schedule is, for example, using timers. Okay, pass the work and come back later. Assign priority to different type of works. Reuse previous complete works. Abort work if it's no longer needed. To go further, let's go back to the concept of React component as function of data, commonly expressed like that. But the way computers typically track a program execution is using the call stack. And because with functions, you can add as many. So when a function is executed, a new stack frame or a new function execution is added to the call stack. The stack frame represents the work that is performed by the function. When dealing with UIs, the problem is that if too much work is executed all at once, so the animations drop frames and looks choppy. But because this is very narrow specific to them. Very narrow specific to them. Because component has more specific concern than functions in general, newer browsers and React Native implements API that have helped address this exact problem. Request idle callback schedules allow priority to be called during an idle period, and request animation frame schedule a high priority function to be called on the next animation frame. The problem is that in the order to use those API, you need a way to break rendering work into incremental units. If you rely only on the call stack, it will keep doing work until the stack is empty. Wouldn't it be great if we could customize the behavior of the call stack to optimize for rendering UIs? Wouldn't it be great if we could interrupt the call stack and at will? Wouldn't it be great if we could interrupt the call stack at will and manipulate stack frames manually? That's the purpose of React Fiber, is to manipulate all of this call stack manually if that you can keep stack in frames in memory and execute them however and whenever you want. This is crucial to accomplish the goal we have for scheduling. Aside from scheduling, manual dealing with stack frames unlock the potential for features such as concurring and error boundary, which we will cover in future sections. Which is because after all of this is wait what? React Core contributors. This group is POS. And admin POS this group in January 31, 2024. What? Basically, the idea of React Fiber is not to use JavaScript stack, but instead unroll what we will normally do on the stack and put it into a heap object. This is inspired by Key works on occult concurrency. Here is an example of Fibonacci. No protect, and this is the call stack. On the console. Result stack, result fiber, stack, fiber, stack, fiber. No protect, Fibonacci 2. And this is result stack, result fiber. Because here you are relying is on the call stack. Oh my, that's one of the reasons why they're using is recursion. God damn it, it all started with recursion. And now how recursion here, fiber, like this, is using an object A0 and B is the tail call, and while true using is now this iterative protocol here, if the function is available here, and an identifier called rec an identifier called rec. Okay, continue rec, continue in the end. Exactly, is a label that you're using there, bro. Exactly, or a label. In contrast to the break statement, continue does not terminate the execution of the loop entirely, but instead, in a while or do while, it jumps back to the condition. Exactly. It jumps back to the condition. Here you are mixing several programming. Okay. So here you say if the argument is less than 2, while true, while true, you're gonna do is this. If the argument is less than 2, you're gonna define its variable sum to store that information, while fiber return added exists, the fiber will return the address. If the fiber.a is equal to 0, then you're gonna sum that, and fiber here is now this new object which contains now a reference to the fiber args here. Okay, so now it contains a reference to this argument, and the return fiber, it will be now it will hold a reference to the object. So the whole idea here is that they are not using is var p performance, var c33, and they call this phi1 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 and b2 b2, and the result stack and the result fiber and the performance on the stack and then here on the performance on the stack here and on the fiber. Result stack and result fiber. Now they are measuring is how many times it's actually taking one and another. Okay, star and n1, and then star and n1 as a way to see how many times it took. God damn it. And this particular algorithm is way much more faster and efficient for that. Or the performance time. Stack and stack. It's not that performance. It means that it's not that performance here. It should that unrolling a stack that has less than 2 times overheat on the most extreme example. It could probably be even more optimized with lower level tweaks. This comparison may seem high, but for real code is significantly less. This is basically only measuring the overheat. This is also only compared to a version of React that use a stack for rendering and only optimize for initial render. It is not what the current is doing. The code isn't actually fully immutable. However, if what the output will be it did right in an immutable stack-based render, something like this, can avoid a temporary stack for using. This is unobservable. Once you have each stack frame of an object, so the whole idea of this is to because they were fire. Oh shit. Works at Vercel. Interesting. Very, 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 very interesting. Very, very interesting. So, the whole point of that, so the whole point of this is to, oh no, why did I do it? Yeah, but the whole point of this is to see that now that particular algorithm that they're using as a way to have much more fine control about which stack frame is being executed, or aka when you run a function, which of them is being executed, to have much more fine control of what's going on. It's like, okay. So this is the data structure and algorithm that they perhaps are using in React 18. Is not is now far more than ever, is now that far away from the VDOM. Okay, but the idea of the React Fiber is to now make it more suitable to work in areas like animation, layout, and animations, layouts, and gestures. So by having this, or by splitting work of rendering into small chunks, uh, into small chunk, by splitting large, by splitting large, by splitting uh, by splitting rendering works into small chunks. uh, okay, by splitting. So by splitting is a rendering work into small chunks, and then spread that into each frame, or then spread that into multiple frames. And all of this frame is just as a way of how now typically a computer keep track of the computer program, okay, or the program's execution. Exactly. So how all of these different pieces is now keep track, how all of these different functions is now being executed. I'm going to keep track I want to keep track the all of this. And by spreading the rendering work into multiple chunks of into multiple chunks, and spread that into each frame, they want is to now make it React Fiber much more suitable to work with animation, gestures, and layout. But this is again very narrow, specific to the UI engineers. And it makes a lot of sense. And it makes a lot of sense. Okay. And it makes a lot of sense. Okay, for UI developers. So, so exactly. So you can think of a single fiber as the virtual stack frame. The advantage of re-implementing the stack is that you can keep stack frames in memory and execute them however and whenever you want. So you have much more fine control about how to keep this data. Okay, virtual stack frame. Virtual stack frame. Now is no long. Now is no. Okay, so the virtual DOM is something that they don't actually use. That is more like the virtual stack frame. The virtual stack frame. But it all boils down is to that this stack frame is the way how my computer keep track the program execution. You can think of this that is how a parent now is keep tracking of what the life cycle of a child or a pet, right? All of the things that it needs to do as a way to guarantee that. So in this case, the program is that all the things that it needs to do to keep track that execution. where the thing go through the entire life cycle. Mhm. Typical stack frame with virtual frame pointer. Stack. Control. Stack frames. They call stack and the stack frame. And that's what the reason why they call it stack frame. And how now when you have the call stack, you have inside of that call stack called as the stack frame function that are added to that. And now that actually complete is the gap here with the call or for the call stack here in the end. Which is a mechanism for an interpreter to keep track of its place in a script that calls multiple functions. So what function is currently being run and what functions are called from within the function. And this is the glossary. The call stack will be empty at the very beginning, and the above code will be executed like this. It's not ignore all functions until it reach to the invocation. Add the greeting function to the call stack list, and we have greetings. Execute all line of code inside of greeting functions. Get to say hi invocation. Get to say hi invocations. And then it's going to add now to the call stack list. Say hi. Execute all the line of code in the same function until they reach the end in hi, which is return execution to the line that invocates say hi. Continue executing the rest of the greeting functions. Delete the say hi function from the call stack. But the idea of this call stack is as a way to keep track. How is as a way to keep track for the computer the program execution, or in other words for ourselves, because after all is that is how can we now keep track at the current execution program, and they do this using a stack. That's what they call this now, stack overflow, when you're passing a lot of frames to that execution stack, program stack, control stack, and runtime stack. But this is now understanding is this mechanism. Stack pointers, frame pointers. Okay. So what is the summary of all of this? You know, what is the summary of all of this? That now React Fiber is this new implementation of the. Okay. React Fiber. Yeah, it's like he won't tell me what it is. He gonna give me his own explanation. There is nothing wrong with that. There's nothing wrong with that at all. Why you don't actually put it here for me? Okay. So React Fiber is the reconciliation. Okay. So the React Fiber is the new reconciliation engine, which is just a fancy name to say. It's the new reconciliation engine, which is a re-implementation, okay, which is a reimplementation of the React's core algorithm, where it is goal is to make it suitable to solve. Okay, so once you understand this problem, mm, it's like okay, it makes sense. What in the f we're doing this? So React Fiber is the reconciliation engine, which is a reimplementation of the React core algorithm that back then used previously the VDOM, where its goal is to make it suitable to solve, where its goal is to make it suitable to in areas like, where its goal is to make suitable in areas like animation, layout, and gestures. So instead of using the call stack, they are now want to have much more control about which stacks are executed, because that's the end of this, you know. So wouldn't it be great we could customize the behavior of the call stack to optimize for rendering UI? Exactly, exactly. So instead of using the call stack, which is exactly, so instead of using the call stack, which is the way how now computers or programs, in this case, how now programs uh, track the is the way how now programs track the execution. Okay, so computers typically track program execution using that exactly, which is now which is the way how computers keep track of program execution. Exactly. And I think this is key for this. So instead of using a call stack, which is the way of how computer keep track of the program execution, and in JavaScript, and so any time we run a function, it is added in to the call stack in JavaScript. They are now they are now want to have much more control about this process, but for UIs. Okay. Okay. Why is that? Because now they want to bring us much more is because they want to engage people to the screen as a way to sell more products and services and that kind of thing. You know, they want to increase its user retention and user conversion. That's all. That's all. But that's the way of doing this. Okay, and now the purpose of React Fiber for implementation of the stack specialized for React components. You can think of a single fiber as virtual frame. So that's the purpose. So that's the purpose of React Fiber. So that's the purpose of React Fiber. a re-implementation, a re-implementation of the stack, uh, a re-implementation of the stack specialized, special, specialized for React components. And makes a lot of things. You can think of a single fiber as a virtual stack frame. You can think as you can think of a single fiber. You can think of a single fiber, okay, as a virtual stack frame, Okay, that's great. The advantage of re-implementing the stack is that you can keep track frames in memory and execute them wherever you want. The advantage is of re-implementing the stack frame. The advantage of re-implementing the stack is that you can keep them in memory and access to that, I will say, and execute them however you need, and execute them however you need. Okay. Aside from scheduling, manually delaying with stack frames unlock the potential for features such as concurring and error boundary, which will cover the structure of a fiber. Note, as we get more specific about implementation details, the likelihood that something may change increase. Please file a PR if you notice any mistake or update information. Okay, but that exactly, this is now implementation. But I'm just going to stick with what they mentioned here. You know, I'm just going to stick with what they mentioned here. What is a fiber? And I said all of this is this implementation of the React ability to, so a fiber, which is now this new reconciliation engine. This reconciliation engine is just as a way to know React to keep track which elements you need to change in the most performant way possible. So this is a re-implementation of its core algorithm that aims to make it more suitable towards animations, gestures, and layout. So what it means is that because they want us to do this, and by looking at how the language works, especially with the stack frame, and how now this call stack is a way of how a computer keep track a program's execution. Hey, where are you currently at, bro? At which line are you currently evaluating this, sis? You know? And if it is, all right. Then, because the way how now JavaScript actually do that is through functions. And wouldn't it be nice to actually have the way or the ability to have control of when we need to execute is our UI, because especially as you now add more and more and more frames, or the more animations you need to add to or the more frequent animations you need to add, the rate drops, or the draw rates drops, or the frame rate drops dramatically. So in that case, well, would it be nice to actually have a way to control? to have a way to know when to execute this uh, uh, yeah, when to execute this stack frame when we need it. And that is the end goal of React Fibers, is that this reimplementation is a way to guarantee that we're going to have now the this reimplementation will this reimplementation will now this reimplementation of the code is the ability that we're going to have to um, yeah, this reimplementation of the code is now the ability that we want to execute our UI element whenever we need it. So they call this virtual stack frames. And this is now, okay, this is the virtual stack frame. Holy moly. So these virtual stack frames and this reimplementation of the stack is now allows us to keep track the state or the frames in memory and execute it however and whenever we need to. Mm-hmm. 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 Okay, and I think that's quite interesting. And I think that's quite interesting as
What's
a way
different
to
from
you
last time,
describe
right?
this.
It gathers up all of those things, and then with the array of things, array is probably an overloaded word. With the list of things that have changed since the last time it rendered, it goes and figures out what the most heuristic set of changes, most performance set of changes to the DOM are to make, and it makes those, right? Like it is one of those things where, yes, if you were going to sit there and handcraft every change on the page, you could probably beat React. But as a general heuristic, it has a set of rules that it applies on what the right thing is to do most of the time, and it works. And that's when it enters the commit phase. It takes this list of changes it needs to make to the DOM, and it does them. It updates the DOM.
It
right?
applies
and,
them to
if you ever use like a ref in React, it also needs to then update those refs, right? Refs are basically references to exact DOM nodes. If it has changed the DOM, it does need to do one more sweep to make sure, like, are all those refs still pointing to objects that exist, and like wiring them all back up. And then we have the cleanup phase. Implicitly in between commit and cleanup, there is this passive effects phase. That's where stuff like use effect happens, right? And as we know, a use effect could call a set state, and we're back, right? And that's why the dependency list matters and stuff along those lines. Mark.
Where do animations happen, and how does that affect rendering?
Animations depend, right? If it is an animation that is done like through CSS, right, then those actually will a lot of times not happen on the main thread. If you are, on the other hand, like taking a DOM node and like changing a value on it, those are synchronous and they happen during, a lot of times like you will be modifying the DOM. It'll either happen through a series of renders, it really depends. If you're doing it on a ref, then it will happen in the commit phase. If you're doing it by changing the state every second, you're just going to go on this Ferris wheel that's spinning very fast through this entire process. But if it's a CSS class, then it will happen like on a different process altogether. Cool? All right. So let's look at this render phase and how it actually works. Basically, the kind of like high level is we've got this idea of something happen. Usually, almost always, that is some kind of state change. It's either a state change or a prop change, but like what's changed in something's props. Eventually, there was a state change somewhere, right? Like the context could change, but a lot of times there's a use state hiding in that context, right? And as I've talked about before, and we will talk about later, like use state is just an abstraction over use reducer. So if it happens in use state, then it happens in use reducer. So we start out with our state change, that triggers a render, and then the heuristic that React uses for whether it should render a child component is, did the parent change, right? There's no like, let me guess, like there's no other heuristic of, the state change will trigger on some parent node, right? And then all of its children will be asked to re-render, right? And then at the end of that render phase, React will gather them all up before them and be like, who is different now, right? But every single one, regardless.
There's a question around, do these changes batch if there's two separate components?
I love questions that I have slides for. I will answer now and then I'll
do these changes batch if there's two separate components?
I love questions that I have slides for. I will answer now and then I'll answer it again because like I'm not going to be rude and not answer it now. So the question was,
There's two separate components.
I love questions that I have slides for. I will answer now and then I'll answer it again because like I'm not going to be rude and not answer it now. So the question was, what happens if we trigger 2 state changes, 3, 5, 10 at the same time, and like, do I go through this rigmarole X number of times? And that question somewhat depends on what version of React you are using. If you're using React 17 and earlier, which is a very real possibility for a lot of people, React 18 has not been out that long, and like,
Exactly.
sometimes trying to get that upgrade prioritized on the old list isn't the easiest thing to do in the world. So there's no shame about that. So in React 17 and earlier, sometimes they were batched. They were batched in an event handler, right? So in and on change, in and on submit, they were batched. There's like a giant asterisk and like 7 other like disclaimers on that. Only in that function.
Exactly. They were batching the event handler.
If that event handler had like a set timeout, or I don't know, awaited a promise in an async function, no longer were they batched, right? So in a very small subset of cases, they were batched in React 17 and earlier. In React 18 and later, which I guess is just React 18 and whatever minor versions on at this point.
No, they automatically
you get automatic batching. Now they are batched across the board in React 18. They will basically run through the code, it will collect up all of the state changes, and then when it's got through that entire process, then it will go and do the next round of state changes. So the answer is it depends. It depends on whether or not you're using 18 or 17. And in 17, I guess it does, if you're using 18, yes. If you're using 17, it depends.
It depends.
Right? In a probably the most common case, yeah. Right? Like, but like also awaiting promises is relatively common as well. Yeah. The heuristic is if parent, like a state change can happen anywhere in the tree, and at that point, it tells all of its children to re-render. Now, really, this graph is like 90% of what we're focusing on today. So there's a bunch of strategies here. One, like right now it's happening at the top of this very simple tree. If you moved it down to one of those, that second row, right, whatever that, if you can make that state change happen lower, fewer things have to re-render. It doesn't make everything re-render whenever something happens. It says from the point that the state changed on down, right? So the further you can push down that state change, which is sometimes antithetical to like what we're told when we're first learning React. It's like, you know, you lift everything up and you pass everything down, but like don't lift it too high is what this chart is saying, right? You lift it too high, you're going to trigger like a lot of re-renders and stuff along those lines. So pushing it down as much as possible, right, is the first and best and arguably not always attainable, but like step one, the first thing that you should try, right? There's like a step two which is like kind of equally as good, but we'll talk about that one in a second. Then, if that one doesn't work and the tree is worthy of this, then it is worth saying like somewhere in the middle, can one of you step in and see if this really needs to continue, right? Like just because that one up there started it, like for me and my family, do we need like nothing's changed for us, like especially like let's imagine this went down like okay we have a node that ends right there, memoizing that one, pointless. Like the act of doing it is not going to cause a render. But let's say on the right side of the screen that goes down 47 more levels. Stopping that at level 2 or 3 is probably worth it, right? Because like again, React does not try to figure it out. It does not care. It is just going to go, right? So where the cost benefit for any of these techniques come to is like how expensive if we kept going down this path at the place that we could have stopped it, right? Like how expensive would it have been, and is it worth it? And that's a point where like yeah, at that point you've done the cost benefit analysis. It makes total sense. But doing it on like a tree that's about to end, probably not even worth it, right? Even if it's like, well, it's re-rendering, it's like okay, like it's fine, like relax. But yeah, they trigger down, they keep going down. So part of it is to push that state change down as far as you possibly can, and the second one is to stop it if you can.
If I recall correctly, at some point there was, in the React there was something like if props didn't really change, the component won't re-render.
Yep.
So that does not necessarily fit in. In the React there was something like if props didn't really change, the component won't re-render.
Yep.
So that does not necessarily fit. And I remember I was confused when profiling myself why it wasn't holding true, like what you described held true, but I clearly remember that like as soon as props remain the same, the child will not re-render. How does that fit here?
Yeah, so there's a bunch of ways. One of which we'll do today. So the in class-based components there was should component update, right? That was a method that you can put in the class one, and that method got 2 arguments, old props and new props, right? And you could theoretically look at them, right? That was a manual way, and we're doing a manual way with hooks. Then there was, I believe you could have a class that inherited from pure component, and pure component was basically a subclass of component that had a should component update that said, just do even a triple equal sign on these 2 things, right? Or just shallowly compare them, and then it would stop it. And I believe for the functional components it might have just been like. It might have been like React functional component, or maybe it was like a pure component version. But yeah, there was a functional component version as well that did the very shallow should component update out of the box, right? The tricky part to that is, one of the things you always have to think about with performance is that like if it was a you should always do this, right, then they would have just built it into the framework, right? And so what happens is a lot of those equality checks were completely unnecessary, right? Like again, it is useful because failing one of those should component updates or React.memo or one of the other ones, very high on a tree that has like, you know, a great to the like 100th power grandchild, totally worth it. But also calling it on every almost dead end, right, would slow your app down more than it would help. And so what happened was people use those components just as by default, right, without thinking about it. Like, well, that one's better because it checks, right? And then all of a sudden they're doing 1,000 of these memoization checks for gains that were less than the cost of doing the memoization check. So those, I believe, they might even still be in there. I don't know. Like should component update, obviously React.memo, which are the manual ones. But yeah, there are ways to do it. But I would still, even if they are still in there, like warn against them because doing it everywhere all the time. Now there is, I think there was a talk about a year ago about like someone you know, working on React County working on a heuristic like where they could actually do it when necessary and not do it when not necessary, right? Like we've seen that sometimes not doing it all the time can be problematic. That's our jobs today. We've also seen from like, you know, the example you point out, like doing it all the time no matter what, also problematic. But like if we could have a computer figure out when to do it, when not to do it, and get it right 98% of the time, again, the gains would probably outweigh the 2% of the time that it calls a memo when it shouldn't, right? So that's kind of the name of the game. So there is like work on this. And like you think about it, the question that came up before about like batching, right? Like there was a little bit of batching in certain cases, and then there was like automatic batching and it worked. So it's like, it'd be interesting a year from now, 2 years from now, the answer might be like, this is, you know, the heuristic has shifted, right? There's work being done on it. But, you know, at this moment, like most of it falls on the things that like, the tricky parts that are left on us with the knowledge of our application, right? Like in the same way we still have to put keys in there because like React doesn't totally know what makes that thing unique. It just needs one piece of information to know if it's roughly the same thing. There's still a few things left on us to do to kind of like inform React about what our intentions are. And so like that's where it comes down to. Like so using one of those like, pure component for the class-based ones, but yeah, using those consistently can be more problematic than not. And so that's just, you know, I think an important thing to think about. We won't spend too much time on this, but this is kind of like an overall like how everything goes down, which is it starts out with a component mounting, which is run the function, call the class, right? Figure out what that original output is. That's the kind of purple section, right? You'll get back some JSX, whether it's the rendered method on a class-based component or the output on a functional one. And that'll all kind of be there. And then like, cool, with the first one, you don't even need to do any diffing, right? It's like, this thing doesn't exist. Go put it on the page. Right on, right? And that's when it happens in the commit phase. And then after that, which is sometimes why using like useEffect for AJAX requests or network requests is somewhat like problematic or tricky because like you wait until you've done everything and then you're like, let's go fetch the data for this component, right? And there's various tricks. Like I think like the libraries like React Query use SWR and stuff along those lines. You know, like I think use SWR will like make a ref that it can cache between cycles. It does some like trickery, right? But yeah, the useEffect will happen after you've already used AJAX requests and will kind of be there. And then like the kind of purple section, right? You'll get back some JSX, whether it's the rendered method on a class-based component or the output on a functional one. And that'll all kind of be there. And then like, cool, with the first one, you don't even need to do any diffing, right? It's like, this thing doesn't exist. Go put it on the page. Right on, right? And that's when it happens in the commit phase. And then after that, which is sometimes why using like useEffect for AJAX requests or network requests is somewhat like problematic or tricky because like you wait until you've done everything and then you're like, let's go fetch the data for this component, right? And there's various tricks. Like I think like libraries like React Query use SWR and stuff along those lines. You know, like I think use SWR will like make a ref that it can cache between cycles. It does some like trickery, right? But yeah, the useEffect will happen after you've already committed to the DOM, and then like we'll clean up effects which might trigger some stuff. Then, like we said before, in that much simpler version of this, right? A use state or use reducer will go ahead and be the thing the catalyst for the updating phase, right? Where we'll figure out what all the changes are, we'll trigger that tree, we'll update the DOM again, and you know things kind of continue and go forward like that. But that is a simplified version of the relatively like involved process of figuring everything out, but it is like, you know, mount it first time and then what changed. Cool. The other interesting ones, because we will use them today, is use memo gets set that very first time, and then use callbacks are kind of pulled in to make sure we're not redefining the functions. If you've never used those hooks before, we'll use them a lot today. Don't worry. You'll have to use them by the end. How about that? That is the kind of like situation we find ourselves in that we are going to be able to deal with. And like under the hood, while this is all happening, from 16 later, which is I believe hooks. Yeah, hooks related to Fiber. Fibers are just a data structure where it keeps track of component interests, its siblings, all those things, trying to figure out how to optimize this as much as possible. This is why stuff like keys are important. This is why the general kind of other advice that I would give you is, like, for instance, if something is mostly the same, but for some reason you're like, I've got this crazy trick where I'm going to switch it from a div to a span, like, those are the things where React's like, I don't even know what's going on anymore, right? And so this is a piece of programming advice I will just give you, which is that really fancy stuff seems really cool, and like the kind of more explicit stuff is like on a long timeline, almost always better for both the computer and your friends. But yeah, fibers are how kind of React wires this all together. It's a data structure. We can keep the kind of previous iterations. It has a structure that's looking at. This is why I say like the whole like, optimize this as much as possible. This is why stuff like keys are important. This is why the general kind of other advice that I would give you is like, for instance, if something is mostly the same, but for some reason you're like, I've got this crazy trick where I'm going to switch it from a div to a span. Like those are the things where React's like, I don't even know what's going on anymore, right? And so this is a piece of programming advice I will just give you, which is that really fancy stuff seems really cool. And like the kind of more explicit stuff is like on a long enough timeline, almost always better for both the computer and your friends. But yeah, fibers are how kind of React wires this all together. It's this data structure. We can keep the kind of previous iterations. It has a structure that it's looking at. This is why I say like the whole like, oh, it's just like a virtual DOM thing. It's like less and less true these days. It's actually, it's grown a bit since 2013. Imagine that, like frameworks change over like almost a decade now, right? So yeah, there are lots of things. This is why the keys are important. It's like, what with the order? Do I need to throw away this entire list or table or what have you? Can I just insert one DOM element? Because sometimes, I did this course on JavaScript performance a long time ago. But like sometimes it's actually cheaper when you're updating the DOM to just blow away an entire section and put it back, right? And sometimes it's cheaper to just add one to the end. And so if you do not give React the information that it needs, it cannot make good choices on your behalf. And then you're like, React is slow. I'm like, is it React? Or are you making poor choices, right? And so like understanding that like there are like complications and that the like whole process in which it does this is not magic is important.
Mine might just be a misunderstanding, but were you saying like semantic HTML is worse than just divs for React, or the other?
No, I'm saying if you like came up with some really fancy technique of like, in this moment I'm going to change it from being a div to a span for this reason, it's going to throw it out, right? Like semantic HTML, great. Consistently semantic HTML, like weird dynamic programming thing that you did to impress your friends.
Out of place.
Yeah, is almost always going to confuse the very delicate, like change it from being a div to a span for this reason, it's going to throw it out, right? Like semantic HTML, great. Consistently semantic HTML, like weird dynamic programming thing that you did to impress your friends.
Out of place.
Yeah, is almost always going to confuse the very delicate set of heuristics that has been fine-tuned over the last 9 years to help you.
So one or the other throughout.
Just like the fancier you get, the more you are walking on the edge.
Okay.
Is there a reason not to auto?
Okay. The fancier you get, the more you're walking onto the edge. Okay. And this is also for life, bro. React Fiber and Render in QA. Okay. React Fiber and rendering Q&A. Jesus fucking Christ. Okay, you got that. The fancier that you get with your HTML, the more you're walking on the edge, the more you are walking on the edge.
The fancier you get,
exactly. The fancier that you get, the fancier you get, the more you're walking on the edge. Oh my God. And I think that's quite interesting. For everything in life as well.
the more you are walking on the edge.
Is there a reason not to auto-assign a unique key, at least to handle the remove and change order to any list?
As long as it's consistent, right? For instance, like, bad ideas, math.random, but like, okay, right, that's a ridiculous bad idea. Other bad ideas, the array index, because that will change every time the array changes, right? But that one seems like, oh, I don't have one, I'll just use that to get React to be quiet and leave me alone. But like sometimes we have, situations where it's like, if you're usually getting something from an API, you usually got some kind of idea to work with, right? But if you don't, then, to your question, the right thing to do is around the time you get that array or collection or whatever, assign everything in there a unique identifier. Like map over it first before it enters your React component. Give them all like even a standard integer that's not going to change based, on the where it is in the array, or UUID, or grab the nano ID like library and just if you need to give stuff, if it didn't come for you with some way, shape or form, like it was just an array of strings that could have duplicates, right? Go through them first and maybe like map them into an object that's got whatever that string was, and then a unique ID. Right, and that will, especially if it's changing in any way, shape, or form. Which, like, on a long enough timeline, assume anything like when you first wrote the code, you're like, this array never changes. If you're doing this more than 3 months, it's changed on you, right? Like, so yeah, I think grabbing it first and like putting a unique identifier from something in some way, shape, or form. I said this in a previous one. I got bit by this one time. We had actually an API with a unique ID, and for some reason, somebody else on my team had used the name of the templates, because it was a list of templates, the name of the templates as the key, but you could have 2 of those. You could have 2 templates with the same name, and it wasn't until I was like, we were doing a migration thing, and I had to like reinvent the thing, and I was like throwing a bunch of dummy data at it, where I had multiple ones, and like React went into a weird mode where like things weren't changing or moving, and it didn't know what to update when, because I had 2 with the same unique identifier, and I thought I had found some unique bug, and then my teammate walked up to me, looked at my screen, pointed at it, and reminded me that it was not the case. But like, above and beyond performance issues, you could also end up with like things aren't changing the way you thought, and you're getting no error messages.
I'd run into similar examples of like, I think it's a unique ID, but it turns out under some circumstances it's not. Like if you do a search and the search result array comes back, and there might be a link to the page for that search result, but if there are multiple matches on a target page, and they both come back as a different search result because they match different parts of the document, they might have the same identifier. So good scenario to, when you get the API response, just uniquely identify each element and then render.
Exactly. If you don't get a unique thing, then you can give it to it upon receiving it and use that to track it. Yeah. Mark.
So we need to be very careful with the context API as it lifts the state up in the tree, right?
Yeah. We spent like a whole hour on that one.
So we need to be very careful with the context API as it lifts the state up in the tree, right?
Yeah. We spent like a whole hour on that one. Like, I'm gonna do the spoiler alert. I'm gonna just spoil it now. We're gonna do a bunch of things to make an app render less, and then we're gonna add the context API to it, and then we're gonna start over. So like, not as we're going through that initial one, just don't get your hopes up. All right. So yes, the question was like, does the context API, which then sits literally, if you think about where you put those providers, you put it around like the application component, right? So they will trigger all sorts of things. Now, there are ways to solve for this. And like, one of the things that you'll notice that like a lot of the other like larger libraries don't have these problems. Like, let's say hypothetically, like, I'm gonna use the context API, I'm gonna use like use reducer, it's like my own, I don't even need Redux, right? You'll notice flashes of green everywhere, and you'll notice you install React Redux, it doesn't. 1, it's just optimized more than you did at the very first thing, and then 2, in React 18, like it is like Redux is structured differently insofar as a store external, and so it's not necessarily like using all the hooks that trigger stuff. It's actually using a completely different hook called use sync external. Might just be use sync external source. I can't remember the off the top of my head, even though I've read the word 1,000 times. But it actually uses a different API, right? That is mostly meant for libraries to interact with, right? That you could totally use too. And if we have free time at some point, I'll show it to you. But like, yeah, using a context API, then you get a new set of things. Luckily, in this workshop, if I might sell you on sticking it out with me, we will run into that issue, we will address that issue, and we'll solve that issue, and then we'll break it again, and we'll solve it again. All right? Fun. I would use green everywhere. And like, yeah, so, all right. So yes, the question was like, does the context API, which then sits literally, if you think about where you put those providers, you put it around like the application component, right? So they will trigger all sorts of things. Now, there are ways to solve for this. And like, one of the things that you'll notice that like a lot of the other like larger libraries don't have these problems. Like, let's say hypothetically, like, I'm gonna use the context API, I'm gonna use like use reducer, it's like my own, I don't even need Redux, right? You'll notice flashes of green everywhere, and you'll notice you install React Redux, it doesn't. 1, it's just optimized more than you did at the very first thing, and then 2, in React 18, like it is like Redux is structured differently insofar as a store external, and so it's not necessarily like using all the hooks that trigger stuff. It's actually using a completely different hook called use sync external. Might just be use sync external source. I can't remember the off the top of my head, even though I've read the word 1,000 times. But it actually uses a different API, right? That is mostly meant for libraries to interact with, right? That you could totally use too. And if we have free time at some point, I'll show it to you. But using a context API, then you get a new set of things. Luckily, in this workshop, if I might sell you on sticking it out with me, we will run into that issue, we will address that issue, and we'll solve that issue, and then we'll break it again, and we'll solve it again. All right? Fun times. All right. Speaking of questions coming in that set me up for making promises, like I said before, we talked about automatic batching, so I won't spend too long on it now. But in React 18, and if you notice, if you just bump up your React 18 from 17 to 18 in your package JSON, you will immediately get yelled at. Without polite warning in the console, which is you're using React DOM.render, you need to use create root, and then from that root render it, right? That is an API change that actually opts you in to effectively some new functionality that gets you this. So if you use, I guess the other it depends on do you get automatic batching is if you've chosen to upgrade to React 18 and ignore that suggestion, then no, you don't, because you're still using React 17 earlier's React DOM implementation, right? And so you get automatic batching if you use the recommended concurrency supporting version of mounting the initial root node. Mark.
Yeah, there's a clarification on how this works. So is React rendering each component and then saving the result of it, and then when it re-renders, kind of comparing the two?
Basically, yeah. Mm-hmm. So
each component and then saving the result of it, and then when it re-renders, kind of comparing the two.
Basically, yeah. Mm-hmm. So the question was, it's saving the output from last time, looking how it's changed. That is how it collects all the data for the commit phase, right? Awesome. Mm-hmm. On the topic of the automatic batching, which is before React 18, there was a way to I forget the name, it was unstable _ batch updates. That might have actually been the name. And you could use that, and React Redux used it, other libraries used it. In the same way that before there was the context API that we all know and love, there was a always legacy, never fully supported, always unstable one that all these libraries used originally as well. And so there's this one that those libraries used. Now that it's supported in React 18 for everyone, I guess sometimes you need to, for some reason, give people the opposite. So if you, for some reason, need to get out of automatic batching, which you better have a real good reason. When that PR lands on my desk, I'm gonna have questions for you. And if it's I totally needed it for this very the burden of proof is on you to use this. Look at how the docs even frames it. It starts out with a big warning thing. Using flush sync is uncommon and can hurt the performance of your app. The burden of proof is on you if you choose to use this one. But I just want to do my due diligence to make you aware that it does in fact exist. If you need it, I've done my job. I've told you about it. If you mention my name in the PR, I will deny every minute of it, despite the fact that this is recorded and live streamed. I have hidden something. We're gonna do this app 3 times. This is round 1. There's 3 rounds. I keep moving the problem around, right? So you do need if you grab main, you won't find an issue because there's nothing hidden in main. But if you grab the initial slowdown exercise, I have hidden a performance issue that you need to find. The game itself is terrible. The game itself is, I took Mark and I were joking about hex codes that make words, and there was a website, and so I grabbed that, and then this basically took a random color, a completely random color of the, I guess, 16 to the 6th colors, and by staring at the color, you have to guess what the hex code is. You're not going to win the game. Don't play the game, right? This was me when I should have been doing more important things during my day, thinking this would be a fun thing to start making, and then I realized I should not be doing this in my time, and I stopped, I put the performance problem in, and I moved on with my life. But there is a performance problem that should, and again, throttle your computer if it's no, it's still fast, and you have a great computer. But typing that input field should be painful. And so spend a little bit of time, and we'll just talk about what's happening, and then I'm going to hide it 2 other places on you later, so it'll be fun. All right, we are doing this. So it's actually not hiding that component. There will be stuff hiding that component later. This one is actually hidden in plain sight. Did anyone find it? I was found
I
it.
think it has to deal with generate random color people.
Yes, it does have to do with generate random color, right? The trick is, I guess there's two things. So find where I put the same thing that slows us down. Right, that's one. And then how do we deal with it is like I think the second challenge. So it is hiding in generate random color. And like, you know, I have produced many a performance issue in my day. This is like I was working on something at work too, where it's like we had to like put something into an error state, right? Like when you're trying to intentionally create performance issues, it's a lot harder. But you know, the where is it hiding will always be like where I just block the main thread for a hot minute, right? But then the question is, why? Yeah.
I think it has to deal with that it's an arrow function. And I think when it causes a render to application, it checks the identity and use state checks, this is not what was there before. That's a suspicion, and it recalls it. Most importantly, it doesn't just recall it once, judging from the profile, it calls it twice, actually.
So everything will roughly have, you know, if you look at just the console for those things, it'll happen twice. But yeah, it's even, like that is the right thread, and it's even a little bit like simpler than that, which is like, is it a React issue or is JavaScript just being JavaScript, right? Which is like, okay, it goes and parses this first line, right? And like, it's like JavaScript still evaluates all the code, right? And so it's like, yo, generate a random number. And so it does, and it passes that into use state. And even in this case, like React is like, I already have a correct answer that I'm holding on to between the keystrokes, because obviously we don't want to have it hand a new one in, right? If the answer changed and the color changed at every keystroke, this would be even a worse game than it already is, right? The issue is that like, as the parser and the compiler is reading through all this stuff, it's like, oh, I gotta go see what the return value of this function is, right? And a little thing like that can be what like slows up the works. Right. So in this case, like, turns out that in the same way, the set correct answer, like, you might have seen, like, you can do, and you can give it a value, right? Like, yeah. But in the same way, the setter also, that one's fine. Can take a function which is like previous value. I'm not going to keep this code. And then does something to it to get to what it should set it to. You can set use state with a value, or you can give it a function that it should call the first time. So by taking this and wrapping it in an anonymous function, right, it doesn't immediately get executed by JavaScript, right? The same way, like, I have made this mistake this week, where you're writing code, you put an on-change handler, you just pass in the function that eventually should be called in there, and it executes immediately, which then, like, it's like a set count or set whatever you have, and now you've spun yourself into an infinite loop before React cuts you off after 1001 re-renders. That's why we put our event handlers in anonymous functions, right? So that aren't immediately called. So that we can pass this in, it will call it the first time, and then set it, and now JavaScript will just see an anonymous function, pass by it won't immediately execute it, and thereby your slow code path is not triggered.
Does calling state dispatch within the main render function logic have any performance problems? The one in application JSX is being set with a Boolean, so state dispatch.
Set it, and now JavaScript will just see an anonymous function, pass by it won't immediately execute it, and thereby your slow code path is not triggered.
Does calling state dispatch within the main render function logic have any performance problems? The one in application JSX is being set with a Boolean, so it won't run into pass by reference issues, but are there any other considerations we should worry about?
So the question was basically, so we have it with this one, but what if, like, these are all primitives, right? And so, like, they are value equality. Even if we had an object, it is taking it the first time. That's what I said before, where, like, React uses fibers to kind of keep track of, like, the kind of a history line of a hook. Like, it's not looking for that value anymore. It has it, it's stored, whatever you've set it to, through other interactions. So even, like, it's not doing an equality check on future run-throughs of this component. But the problem was this code was executing before it even got into React, right? JavaScript itself, you know, the JavaScript compiler was stepping in, running generate random color, producing a random color, which was expensive, and then handing it to use state to be ignored. Mark.
Could you please step back and show how we can see this performance issue first? Because it feels like we're fixing a problem that we haven't measured.
Absolutely. I mean, one of the best ways. Oh, I fixed it already. Hold on. You can't measure the fixed one. We got to go in.
I'd also bump the block for a little bit to make it even more obvious.
We can bump or throttle. Yeah, both are, I think, are options. Let's throttle. Let's use the tools, right? Like, rather than like increase the fake thing, let's use the real tools in this case. All right. So we go into performance. Right. And we've got a bunch of different ways we can handle this. Right. So we can go ahead and start by looking at the profiler. Right. But like I said, like one of the heuristics, like I think for me, one of the places where I immediately know that I have a problem is like the one place, I think what Google has, I think it's like Rail, and it's like, there's a set of like heuristics for how you actually think about performance, and one of the ones is response time, right? Like the moment you are interacting with any way and it is feeling slow is a time to start looking, right? So in this case, we could theoretically, and I'm even typing and it took forever to like, so you can see as we're coming in, we're taking 304 milliseconds to render, right? And so like when you have a chart that like even in and of itself is showing that on every keystroke, we've got these incredibly like long, like 300 milliseconds. You're aiming for 16, right? Now, granted, yes, this is a like purposely like slow find the React like quirk that made this happen, or in this case, a JavaScript quirk that React didn't need or want. But we can kind of see it in the tools. And then the other great way to do this is you can actually see that like I got a little like heads up over here as well. That's because I have the CPU throttling. Let's see. The other way that I will very frequently do this, and again, this kind of goes to Alex's question of like, which set of tools do you use? Scroll down. Is a really great way is Chromium, right? So depending on which browser, will flag anything that it thinks is problematic, literally with a red flag, right? And so like, if you run a profiler and you see like anything with this little red thing, it's like, hey, that took way too long, right? And like, I'm just gonna tell you now, there are things that you didn't think were bad that it still feels as bad, and like it will hurt your feelings. So like, be aware of that, right? But we got a 300 millisecond like lag in the application rendering, right? So we can tell it was pretty high up there, right? If we saw it like lower down, and that was if application was this big wide bar, but then underneath it there was another equally like wide bar, which when we find the bug, not to spoil it for you, like you will see. But like, that kind of shows you the depth of that flame graph and how wide, like, shows you how deep in your component hierarchy it is. The other thing is you can see that we are, you know, peaking, like, and again, this is intentionally blocking the main thread, right? But you can see, like, we get flags here, and as I said before, you wouldn't see this in production. Like, application, and then generate random color, right? Those, like, wouldn't have their names in the production build. It is the providing of all that information, which, again, doing stuff is slower than not doing stuff. So in production, it does not do these things. Technically, unless again you work on a developer tool, a lot of times your customers are not the ones like debugging and triaging your performance issues for you, right? Like, so you don't provide them all that stuff because it slows it down. But for us, we can actually see like what function was the one kind of calling it in this sense. And get a sense there as well. But yeah, the red flags and looking at that CPU graph, but then also seeing like which component it is, like, and as we play the game a little bit more, we'll see it a little bit more. If it's hiding down a level, you'll see where the white part of the flame graph was and kind of get a sense of what it is. This one was literally the second line of the root thing, so it is a long and sad, but relatively simple graph.
You had mentioned 60 milliseconds. Is that like a heuristic we're trying to hit?
Yeah, that's heuristic.
Okay.
Yeah. I think the heuristic is like refresh rate of 60 frames a second divided by 60, 16.66666, so on and so forth, right? And so like beating that doesn't really do you any good because, you know, and yeah, the screen refresh is 120, yada, yada, yada. But yeah, that is why the heuristic exists. It depends, like most things, right? Like, you know, I work at a company that also needs to like make money, and me getting it from like 20 to 16 is not always gonna get me adulation. Right, like, and so it's always you know, there's what we should aim for, and then what is like practical, so we continue getting a paycheck as well.
Kind of along those same lines, a number that I circulate with Adam because he works on one of the teams that I work with is generally speaking, humans can't perceive anything less than 50 milliseconds. Mm-hmm. So if you have a single render cycle that takes 50 milliseconds, you're probably okay. Yeah. But it definitely adds up if you get in a render loop and you stack them up. So
I forget what the threshold for the Chrome tools yelling at me is. I know the 300 obviously passed it, but I don't remember off the top of my head what it is. Mark.
Maybe you're gonna do this, but could you fix it and then see it again?
And Alex, why don't you ask me a question while I fix it?
Yeah, so I think this was a great example when we actually need to combine the React profiler and it looks like when the issue is with the JS itself. This is right because the React profiler wasn't particularly specific in terms of where
it showed you like what component it was in, but it didn't show you in the same way that this did, right? Like, yeah, like all the fixing re-renders in the world is not going to save you from your slow, just regular JavaScript, right? Like, But yeah, using them together will then help you, at least you find as a concerted effort. Let's do this one first since we're in here. So I believe, so I added the anonymous function. All right, and now you can see I don't have those long peaks, right? The probably initial render is still somewhat unhappy with, because it does call generate random number once, right? Like that function is still slow, right? Like, so like I do get yelled at over there, but you can see that subsequent re-renders are not calling the issue in this case. And let's do it, let's pull up the, as well. Right, in this case now we're at 2.1 milliseconds, right? And we are, probably the other time that those are probably in existence, but probably so tiny in comparison. Like they can make a bigger appearance in a 2.1 millisecond line than they can in a 300 millisecond line. But yeah, are there as well, since we're probably so, let's do it, let's pull up the, as well. Right, in this case now we're at 2.1 milliseconds, right? And we are, probably the other time that those are probably in existence, but probably so tiny in comparison. Like they can make a bigger appearance in a 2.1 millisecond line than they can in a 300 millisecond line. But yeah, are there as well. Again, these are kind of like, you can see like game input was changed at this point. Like you can see like what changed each time. Expensive component is not expensive yet. It will be. You can guess where I'm moving the problem next. But next you don't get to just like figure out where it is. You gotta do something with the component. So it's like, I can name it a little bit more obvious next time.
But I guess the other issue is that our input sets stayed on each key press, and we should probably debounce that.
I mean, that depends, right? Like debouncing, the act of debouncing it, like on the input, you don't really get to debounce it, right? Like you do have to update the input when they hit keys, right? Like you play a game where it's like, sure, you'll be calling less things, right? But if, again, that comes down to that like heuristic of, did it take, like 2.1 milliseconds? Right, and is it like, what are you going to debounce? Like, you're going to wait for how long until you show them a keystroke, right? And so it becomes a little bit tricky. And does the cost of debouncing add more? So on and so forth. Now, if they were typing, and this is actually like the example that we end on, which is the final example in this, like, in our time together, is a form where like loading and filtering the list takes forever, right? And like, how do you like concurrent react, update the input while waiting on the list? So like, should you debounce, like hitting the network on a autocomplete for a search? Yes. Right? Should you debounce rendering everything else, but I think like prioritizing the feedback for the user that they did the thing, right? You do usually, that's what, the difference between what is an urgent update and what can wait a little bit, right? Like, especially like there is a certain amount of, like insofar that network requests take time, there's a certain expectation that things aren't always immediate, but like me typing should be, right? Me clicking on a thing, I should get feedback, right? The idea that the network request goes out and comes back or something happens, there's a certain amount of grace for that, but like, if I hover over a button, it should change. If I type in an input field, it should respect that feedback. If I click, I should get that response. Those are things like, I think we've all used enough UIs in our life to know those are the things that drive us absolutely nuts. Yeah,
Yeah, I think if we debounce these defects, will be very similar to what we're seeing right now.
Yeah, like we'd purposely create the issue, right? We are just we have a set of conditionals here, and we're just gonna call it, right? Should we do a use effect to let it finish its thing? So on and so forth, right? Like doing the use effect would let it finish and then go for it again, like do the whole commit phase. It's tricky with concurrent react, like if there was this would count as an urgent update because we haven't, like things are urgent unless you say they're non-urgent. Like this would stop a non-urgent thing because it's counted as urgent. So maybe you would want that. I mean, this app is one that's supposed to intentionally have problems. So yeah, you can find a few more in here too, and you will. But like with this one, like would I put in a use effect? Probably not. Would I put it maybe in a use memo, which is like, hey, only even try to figure out like if any of these things it depends on have changed. Right? That might make a lot more sense in this case. Here we're going to check no matter what. But like, yeah, like I don't know if I would use a use effect, but I would probably use a use memo, right? To be like, run this function, right? If and only if the things that it even cares about have changed at all, right? And what we said before, React is for every hook, React is keeping track, almost like has every version of it as kind of this like almost like linked list like structure, right? It knows when these things changes to trigger a use callback, to trigger a use effect, to trigger a use memo. But like since use memo has a dependency list and then recalculates a value, setting a use effect to have a dependency list and then go manually set the thing is just like, I would use use memo probably in this case, but then also like
So why not do
this is
use
just flipping a Boolean too,
effect?
right? And so like the question there is like, we could play a game of like, let's measure it, but they would probably both be infinitesimally nothing. All right. So the question was like, why is it bad this way and not the other one? Is like the simplification of the question, right? This one is like almost not, it's React adjacent, but not necessarily a React thing, which is before this ever even gets into use state, right? We're like, JavaScript's going along, it's like, yeah, const, I love const, right? Oh, it's gonna be stored, it's gonna be a tuple that we split up into an array. I love it, I'm here for it. Oh, look, a call to use state. I wonder what we're gonna hand use state. It then gets to this like generate random color, which is being called immediately. JavaScript, which is single threaded, right? Blocks the main thread, says, oh, we're calling this. I need to get the return value of this function right now, right? And that is our slow function. It gets the return value. The hooks in React only care about that value the first time they're ever called, right? That's why hook order matters. If you ever like try to put like a hook in a conditional, React is like, absolutely not, right? Like this is all held together by like, it's both very sophisticated and very fragile at the same time, right? That's why if you have anything, like you put the hooks in a for loop, React will yell at you. You put the hooks in a condition, it's like the order of the hooks matter. And so when React sees like, hey, this is a second use state, like I already had a value for that. I don't care what gets passed in. JavaScript stopped what it was doing, halted everything, ran your super expensive function, and then handed that return value for React to throw it on the floor, right? When we wrap it in an anonymous function, and maybe we start with the character at the beginning, we say, it just parses, oh yeah, this is a function, cool. I don't have to call it yet because this is like an uncalled function, right? Hey React, if this is your first time with this hook, go run this function and it'll give you the initial value. And React, again, is like, I've already run this hook before, I'm aware of it, it's the second hook. It's the second hook of the like 4 that are happening in here, or 5, I guess. And like the use, like it's these that have to be in the right order. Like the sets can obviously happen wherever. But like it's the second of the fourth of the 4 hooks that I know about. I already have a value for that. Thank you for this anonymous function, which happens to be expensive. I will be throwing it on the floor now. And it is never called. And not calling the expensive function is faster than calling the expensive function.
Why, after every keystroke, wasn't it like giving you a different answer, like you said earlier?
Yeah. A new color was getting generated, right, by JavaScript, and React didn't care.
Oh, okay.
React like, I have the first one.
Earlier.
Yeah. A new color was getting generated, right, by JavaScript, and React didn't care.
Oh, okay.
React like, I have the first one. I'm not, like, it's like, imagine there's a conditional, this is not how the code is written. Imagine there's a conditional, if this is the first time the second use state hook is called, I care about the value. If not first time, no op, right? And so it's like, you did all that, like, JavaScript did all this work on this expensive function, handed it over, and React was like, hey, nobody cares. Like, I'm uninterested in this. Thank you for this gift. I am going to go put it in the other room and never look at it again. Yeah. The other question is like, is it not always best practice to have it to bounce? Yeah, like I said before, on an input field, like, generally speaking, for most performance advice, it is never and always, right? Like, it is, otherwise frameworks would do it out of the box, or the DOM would, I mean, you can't trust the DOM to like adjust the stuff, right? Like, but generally speaking, like it would be just kind of in place by most frameworks or things along those lines. But like that is probably not always the UX you want. Now, should you to bounce the side effect from that change? Should you to bounce it's slamming the server as you're like typing out your like magnum opus and to search for the the whatever Pokemon you're looking for? Absolutely, you should bounce because you don't want to like slam the server because like they're still typing, but you should show them the characters that they're typing, right? So there's like you should bounce things about the input field, absolutely, right? The actual like not because React is not going to change the contents of the input field. Like if you take off the onChange handler, you can hit buttons all day, it will just never show it in there. Other frameworks might with two-way bindings and stuff like that handle, but like unless you change the state, you will not see the letters you typed in that like input field. So like it will look like I said before, it will look like you like have the performance issue in there. So the question was, did I get it right? The first version of the function generate random color was still called on every stroke. It just didn't update the state. Yeah, it was called. It was expensive. And so now we're saying like, hey, use state. Only call this if you think you need it. And after the first one, it's like I don't need this. And so it doesn't get called. And not calling the expensive function is way faster than calling it. Exactly. So we are going to take a small.
Okay. That'll be all for this video. Take care. Bye.
A little lab and figure